Good morning, Math 137 friends. Welcome to our virtual intermediate algebra lectures. Fortunately, we ended before spring break with at the end of chapter 7. Don't forget you have your chapter 7 test on this coming Thursday, which I believe is, whatever the date is, the 26th perhaps? Yep, the 26th. I will be sending out details in the next day or two regarding that exam. It will be taken on Alex. So be prepared to take that exam sometime during the day on Thursday, the 26th. Today we're going to start with our Chapter 8 lessons, quadratic functions. Quadratic functions are second degree polynomials. We saw these pretty regularly in Chapter 6. Second degree polynomials means the highest power on the variable in the equation is 2. Some examples of quadratic functions would be y equals 4x squared plus 2x minus 6, for example. There can be at most 3 terms in a quadratic function, up to 3 terms. Because it's a function, we can rewrite it using our function notation. Either way is acceptable. A simpler quadratic function might be something of the form 7x squared. So what makes a function a quadratic function is that the powers on the variables are all integers, the highest one being 2. So second degree polynomial, second degree polynomial. So in chapter 6, we solved quadratic equations by taking quadratic functions, setting them equal to 0, using the zero product property and factoring. But we also came across situations where polynomials were not factorable. And in chapter 6, we didn't have to solve any of those. We avoid that situation. Chapter 8 is going to teach us how to solve any quadratic equation or a quadratic function set equal to 0 with different methods. So today we're going to talk about solving quadratic equations using the first method called the square root property. So solving quadratic equations, I'll abbreviate quadratic equations with QE in the notes. So quadratic equations are quadratic functions that can be rearranged and set equal to 0. So quadratic functions that can be rearranged and set equal to 0. Now, we don't always set it equal to 0. It depends on the process we're using to solve. So let's suppose I had something like this. X squared equals 3x minus 4. That's an example of a quadratic equation. We can rearrange it by subtracting the 3x and adding the 4 to each side and creating what we call a quadratic equation. And our goal, again, here is to solve these and find solutions that make this a true equation. In chapter 6, we solved quadratic equations by factoring. So for example, solve x squared minus x minus 6 equals 0. And what we did is we factored, and we said, what two numbers can we multiply to get negative 6 but add to get negative 1? So negative 3, positive 2 equals 0. And then we used our factor, and we got from this factor that x would be 3, and from this factor x would be negative 2. So therefore, my solutions, we can go back and check because that's the right thing to do, are 3 and negative 2. Well, factoring works great if your polynomial is factorable, but if we go up to this guy and we try factoring, you'll see there are no two nice numbers that when we multiply together we get positive 4 and we add and get negative 3. So this is not factorable. We need an alternate method. So, that being said, we're going to introduce the square root property. In the square root property, we're going to take baby steps sort of towards the bigger picture. So I'm just going to introduce the square root property in this lecture, and then in the next one, because I'm only really going to do about 15-minute lectures here, because anything much longer than that takes way too long to download. So the square root property, now we have used this in the past We just didn't have a name for it. If I asked you to solve x squared equals 25, well, my answers, what can I square to get 25? In other words, I'm looking for the square roots of 25. We know the obvious answer is 5, but don't forget its negative counterpart, -5. And how did we get 5? Well, mentally, we thought to ourselves, what number do we square to get 25? So in other words, we took the square root of 25, and that gives us 5, but also -5 times itself. So don't forget the negative buddy. The negative solution. All right, so we actually we solved this by observation, but we could solve it by factoring. This is the same thing as saying x squared minus 25 equals 0. We notice this is the difference of squares, x minus 5, x plus 5, and then using the zero product principle, we get x equals 5 and -5. So, yeah, okay. So we could factor this one. Not all are going to be factorable. So let's look at this guy right here. Let's suppose I asked you to solve this. X squared equals 8. All right, what can we square to get 8? Not so obvious. If we rewrite this and try to factor, it's not the difference of squares. So what's going to help us here is this new property called the square root property. So the square root property says, again, I'll abbreviate this, SRP, says, if something squared equals a number, we can square anything. Something squared equals a number. Now, typically what's going on in here is going to be the variables what's going to be inside this box somehow. Then something squared equals a number, then that something equals the square root of the number, or that something equals the opposite of the square root of the number. And you're all familiar with the corny cloud with stars. So that's important. Right there. So if we go back and revisit x squared equals 25, well, x either equals the square root of 25, which is our 5, or x equals the opposite of the square root of 25, which would give us our -5. So let's see how that can help with this example. X squared equals 8. So by the square root property, we can now solve x squared equals 8. The square root property says if something squared equals a number, then that something, so what we're squaring is just x, so the square root property says x is either equal to the square root of 8 or x is equal to the opposite of the square root of that number. It always has to be a number on the right side of the equation. Anything that involves x will be on the left side. So there are solutions, almost, because we still have to practice what we covered in chapter 7 and be sure to simplify all radicals. So we know that 8 can be written as 4 times 2. So x is equal to 2 square root of 2. And over here, I do them separately. X is equal to the opposite of the square root of 8. Well, the square root of 8 we just saw is 2 square root of 2. So therefore, my solutions are x is equal to 2 square root of 2 and -2 square root of 2. So now we can solve any quadratic, any number, anything squared equals any number. It doesn't have to be a nice perfect square number over here on the right side. Oh, yay. All right, so let's try another one. Let's suppose I asked you to solve this. Solve. And I said x squared plus 4 equals 0. Now your first instinct might be to try to factor this, but it's the sum of squares. And if you remember, the sum of squares without a greatest common factor doesn't factor, so we can't use factoring the zero product principle here. But I can put it into the form something squared equals a number by subtracting 4 from both sides. And then I'm going to apply the square root principle, or the square root property, that says if something squared equals a number by the square root property, what we're squaring here again is just plain old x. So x is equal to what we're squaring either equals the square root of the number, or what we're squaring equals the opposite of the square root of the number. Whoops, don't lose the -4 in there. So x is either equal to the square root of -4, or x is equal to the opposite of the square root of -4. Now we simplified this using what we learned in chapter 7. X equals, well, a negative under a radical corresponds to I outside. So I is equal to I square root of 4, or x is equal to I times 2, and that's just awkward, so we write the solution 2I. And then we go work on the other side. X is equal to the opposite of, well, the square root of -4 we just saw is 2I. So square root of -4 is 2I, so the other solution is -2I. So therefore, my solutions are x is equal to 2I and x is equal to -2I. So there is the most basic explanation, or the most basic examples using the square root property. Definitely gets more difficult, so we will work on that in a second. My instinct is to say, does anybody have any questions? But you probably do, and if you do, then you're going to use Zoom. My office hours for this class are not convenient for you. As always, you can contact me and we can set up individual meetings. All right, so let's keep going. Keeping in mind, the square root property says, if something squared equals a number, we can put whatever we want in there, as long as this is numerical out here, the variable is in there, then that something is either equal to the square root of the number, or that something is equal to the opposite of the square root of that number. So for example, solve. X plus 2 squared equals 24. Now back in chapter 6, what we would do is we would distribute. We would do x plus 2 times x plus 2, being really super careful not to distribute the power through addition or subtraction. Would subtract the 24, would set this equation equal to 0, and then we would try factor it. Problem is, in this case, you can try it. I'll let you do that on your own. If you square this out, subtract 24, you get an expression that is not factorable. So you would have done all that algebra for nothing. So when it's set up like this, something being squared equals a number, it's screaming to use the square root property. This time, though, what's being squared is not only the x, but the 2 also. Again, be super careful. You may not distribute that power through addition or subtraction. We all know what horrible things that happen when you do that. So if it's something squared, even if it's x plus or minus a number, equals a constant, we can apply this property. What is being squared is x plus 2. So this is screaming to use the square root property. The square root property says take what's being squared, x plus 2, and it equals the square root of the number over on the right side. So that's that part of the template. Or what's being squared is equal to the opposite of the square root of the number. So now we have 2 little mini equations to solve. Again, keeping in mind our properties from last chapter, chapter 7, you're still responsible to simplify all radicals. So square root of 24 is 4 times 6. So x plus 2 is equal to the square root of 4 times the square root of 6, which is 2 square root of 6. Now we solve for x by subtracting 2 from both sides. Now here's where we have to be a little bit careful. The suggestion is, just like back at the end of chapter 7, when we talked about complex numbers or imaginary numbers, we would write them in standard form, the number plus the real part of the number plus the imaginary part of the number, and that form's going to be significant in this section. So likewise, form here is significant. When you have a radical left over, that cannot be simplified further. My suggestion is, if there's a constant here to add or subtract, when you bring it over to the other side, we're going to get x equals put the radical part of the number second and the nice non-radical part of the number first. So I would write this as -2, and there's really like a positive right there. So plus 2 square root of 6. You can write 2 square root of 6 minus 2, but it's not suggested. Okay, and I'll show you why, because when we come over here and do this solution over here, we're going to get x plus 2 equals, well, we know the square root of 24 is 2 square root of 6, so now we're at -2 square root of 6. I bring the -2, or subtract 2 from both sides, and I get x is equal to -2 minus 2 square root of 6. So if we look carefully at both of these numbers, there is a relationship here. And this is not a coincidence. This will always happen. So we get -2 is the nice part of the number. 2 square root of 6 is what we call the irrational part, or the radical part of the number, and then sign in between just changes. And the sign only changes in front of the radical part. These numbers are conjugates. So these are conjugates. So my solutions, and it's not a coincidence, when you have solutions in that involve radicals that cannot be simplified, they always come in conjugate pairs. So -2 plus 2 square root of 6, without even doing the work over here, based on my experience and what will soon be your experience, you'll know that the other solution will automatically be the conjugate of this answer. So we wouldn't even actually technically have to do that work. All right, so looks like I'm pushing my time limit. So this is going to be continued. 8.1 part 2. So I'll see you in a few minutes.